Hello, we're going to present our solution for the signal conditioning system problem situation for design of electronic circuits. I am Axel Pérez.
I'm Minauro.
Julián Camargo Patiño.
Well,
These are the contents.
the objective of this challenge is to make, we've got a CO2 sensor which outputs some voltages, and we are asked to do a signal converter that has to pass through a filter of a maximum of 50 hertz.
So now going into more specific terms, we basically get this base sensor. It's a CO2 sensor with linear response. It has -1 volt when it's at 0% concentration and 5 volts when it's 100% concentration. And what we are asked to do essentially is to modify this CO2 sensor and get it to -3 volts when it's at 0% concentration and 3 volts when it's at 100% concentration.
The first or most integral part of the circuit is going to be a differential amplifier, which will take the signal brought in from the 5 volts from -1 volt to 5 volts to -3 volts to 3 volts. The first iteration of this we tried to build didn't work as well because we didn't have the necessary resistances for the inputs, but using these formulas, we managed to figure it out that for our our inverting input, it had to have a resistance of 500 ohms, and its feedback had to have a resistance of 200 ohms.
Well, then using the formulas for the second-order low-pass filter, we were asked to do the filter that has a maximum of 50 hertz. For this filter, we had to do trial and error with the resistor and the capacitor values. Since to make this, we are able to assign the values for each resistor and for each capacitor to the same, giving us at the end a formula that the frequency has to be equal to 1 divided by the value of the resistance and the capacity multiplier. So, well, our first iteration had a capacitor of 1 farad and the resistance of 20 ohms. This was as much as it could work. It was gonna be way too difficult to see real results while doing an assimilation, since it was gonna be way too long. So we had to do more try and error until we had a capacitor of 0.02 microfarads and resistances of 100k ohms. This way we were able to obtain our filter. It was able to get frequencies of 50 hertz and in less time, so that it was visible. The only problem that it was that once the signal entered, it came out as negative. So,
Well, as Ivan said, so our solution here is basically making an inverting amplifier. It essentially takes 5 volts and then turns the signal upside down basically, and then gets another 5 volts out, maximum and minimum. And well, here we can see the full circuit assembled. We took each component, and then we put them here together. We've got first the filter over there at the left part. Then it is directly connected to the inverter because we need to invert the signal because it comes out negative. And then we put that in the main circuit.
and well, after we finished this full circuit, we were able to see how manipulating the signal was of real use, since we were able to achieve our end goal. Uh, Also, well, in essence, the only thing that was required was the inverting amplifier circuit. That's the most right part. In essence, it just subtracts 2 volts from the main voltage, giving us our -3 volts range. since it's still a linear response. We were able to complete the filter, but and it filters frequencies above 50 hertz as it was required. And just to finish it up, we added the inverter. It's also worth mentioning that since the signal has to pass through so many components, we have a loss of around zero point 0.1 volts, which is not a lot, but it's worth mentioning. And well, that would be all for us.
Thanks for
Thanks
watching.
for watching.